Hi everyone, today we're going to do lesson 6 of Unit F, which is optimizing surface area. This first question asks us to determine the surface area of the pyramid. To begin, let's look at the formula for the surface area of a pyramid as found on our formula sheet. This formula has a list of all the different component parts for the surface area. It shows us how to find the area of the base. B squared in this case means that it's looking as though the pyramid has a square base. Our pyramid doesn't have a square base, so we're going to have to adjust for this. Our base is a rectangle, so we're going to have to use the formula length times width of our rectangle in order to find its area. Our area can be found by doing 4.3 multiplied by 3.2. This will give us 13.76. So we know the area of our base will be 13.76 centimeters squared. Now we'll need to find the area of the triangles on the sides of our pyramid. Once again, the formula sheet is assuming that the base is a square, so all of the base measurements would be the same in the case of the formula. This means that all of the triangles on the sides of the formula's pyramid would all be the same. That's not going to be true for our pyramid. So what we're going to need to do is use the general formula. The total surface area is equal to the area of the base plus the area of the 4 triangles. And then we're going to imagine what the net of our pyramid would look like. So we'll know that there will be a rectangle in the middle, and then there will be a triangle coming off of each of the sides of the base. 2 of those triangles will have a base length of 4.3 centimeters, and the other 2 will have a base length of 3.2 centimeters. All of the triangles will have a slant height of 7.4. We'll be able to use the formula for the area of a triangle being base times height divided by 2 for each one of our triangles so that we can find the total surface area. Our total surface area will be calculated by adding the area of the base plus 2 times the area of our green triangle plus 2 times the area of our blue triangle. When added all together, this will give us a total surface area for this pyramid of 69.26 centimeters squared. Question number 2 asks us to consider if the slant height of the pyramid were doubled, what would the new surface area be? If we consider the net that we drew in the previous question, we'll know that the 7.4 will be doubled to become 14.8, but all the other measurements will remain the same. Our area of our base will still be the same as it was before, 4.3 multiplied by 3.2. Our area of our triangle calculations will change, and that will be multiplying by 14.8 as our height in each case. So when we go to determine our total surface area of our green triangle and our blue triangles will have changed, they'll have increased. So our new total surface area will be 124.76 centimeters squared. So we'll notice that our new surface area hasn't quite doubled the original surface area. This question is asking us to consider if the surface area of a rectangular prism is 550 meters squared and it has a length of 15 meters and a width of 10 meters, what its height would be. To explore this, let's look at the formula for the surface area of a rectangular prism. Let's consider the formula and substitute the information that we already know. We know that the length, or L, is 15, the width, or W, is 10, and we know that the surface area is 550. We don't know the height. This is what we're going to need to find. So let's simplify what we can. Inside the brackets, we can do 10 times h and leave that as 10h. We can multiply the 15 times the 10, make that 150, and we can multiply the 15 times h to make that 15h. And now we have some like terms that we can collect. The 10h plus the 15h will give us 25h. Now we can use the distributive property to distribute the 2 into the set of brackets. So we'll have 2 times 25h, or 50h, plus 2 times 150, or 300. Now we can move the 300 to the other side of the equal sign, and we'll have 550 take away 300, which would be 250, equals the 50h that was remaining on the right-hand side of the equation. Now, to isolate h, we'll divide both sides by 50. 250 divided by 50 will give us 5. So we'll know that the height must be equal to 5 in order for the surface area of the rectangular prism to be 550 meters squared. Good luck with your work finding the surface area of various 3D figures.